Hello and welcome, and in this video we're going to introduce imaginary and complex numbers. Now you might be saying, what in the world is an imaginary number? And to talk about that, I want to first introduce all the different number systems that have been created by man throughout the ages. All right, the first set of numbers that we really had were the natural numbers. Okay, these are also sometimes referred to as counting numbers, like 1, 2, 3, 10, 17, and so on and so on. These are what we call the natural numbers, okay? This is part of the natural number system. And then quite some time later, we discovered a number called 0. And with that, we got whole numbers, which took all of the natural numbers and just added 0 to it. So whole numbers are numbers like 0, 1, 2, 17, 38, so on and so on. Then, after that, we started talking about integers. We started thinking about, well, what about negative numbers? We understood the concept of negative numbers. So integers take all the whole numbers, which also take all the natural numbers, and add negatives to it. So we have numbers like 1 and 7 and 18, and also -2, -5, and so on and so on. Those were the integers. And then sometime after that, we started talking about rational numbers, which once again swallowed all of those other numbers, integers, whole numbers, natural numbers, and just introduced rational numbers, which are numbers like 1/2 and 2/3, a fraction. All right, these are fractions. All right, and with rational numbers came some numbers that didn't work rationally, numbers like the square root of 2 and pi and e and stuff like that. And that's what we call irrational numbers. And they're actually completely separate from all the other numbers that we have talked about so far. And once again, these are numbers like square root of 2, square root of 11, e, pi, stuff like that. And that makes up the real number system. And we always kind of think about things in terms of real numbers, right? When you're going to the grocery store and you're counting how many bananas you got or something like that, and how much it's going to cost, or how many gallons of gas you pumped, you're always thinking about real numbers. However, that isn't the only number system, because quite some time ago, we discovered and kind of invented the imaginary number I. And I know what you're thinking, but imaginary numbers are actually very, very useful in a lot of different fields. A lot of engineering and quantum computing and stuff like that do use imaginary numbers. And what imaginary numbers allowed us to do is to actually solve equations where we ended up with a negative underneath the square root. And we'll talk about that in just a second. And with imaginary numbers comes an even bigger number system, which we call the complex number system. And notice the complex number system actually is all the real numbers and all the imaginary numbers. So this is an introduction to the imaginary number system and the complex number system. So let's go ahead and take a look at this. So now that we kind of talked a little bit about what the complex number system is and how it engulfs the entire real number system as well as imaginary numbers, let's talk quickly about the standard form of a complex number. All right, because there is a standard form, and that standard form is a plus bi, where a is the real part of the complex number and bi is the imaginary part of the complex number. And what I mean by that is that we can have a number like 2 plus 3i, and that would be a complex number. 2 would be the real part of the complex number, and 3i would be the imaginary part of the complex number. So you've actually been dealing with complex numbers your entire mathematical career without knowing it. You've just been dealing with complex numbers that were missing the imaginary part. Numbers like 3 could be thought about as 3 plus 0i. Numbers like -2 could be thought about as -2 plus 0i. So you just weren't seeing the imaginary part yet, okay? Now, the reason that they were actually made back in the 1500s is because for hundreds and hundreds of years, mathematicians would come across equations such as this: x squared plus 1 is equal to 0, and they would attempt to solve it, right? They would subtract 1 from each side to get x squared is equal to -1, and then we would take the square root of each side to get x is equal to plus or minus the square root of -1. And if you remember anything, you should remember that you cannot take the square root of a negative number. There is no such real number that when you take the square root of, or that when you square it, you would get a negative number. And that's true, there is no real number, but there is an imaginary number. and that number is I. I is equal to the square root of -1. So this actually allows us to now solve all sorts of new equations, because up until about 1542, I want to say, equations like this right here would just be thrown out. Like, okay, there's no real solution, this is useless. But it's actually not useless at all. So a mathematician invented the imaginary number. He didn't actually call them imaginary numbers. That happened a couple hundred years later. Actually, a mathematician, Rene Descartes, he actually sarcastically was like, who, the imaginary number? Because he didn't actually like it. They didn't really see the connections for imaginary numbers yet. But that's actually why we call them imaginary numbers now. And a very famous mathematician by the name of Leonard Euler actually first started using the letter I to denote the imaginary number. Fun little fact right there. So I is equal to the square root of -1. And what this allows us to now talk about is all the different powers of I. If I were to square I, I'd end up with I squared, which means I would square the square root of -1, which would cancel out the squares and give me -1. So this is the first number, and pretty much the only number, that when you square it, we end up getting a negative real number. And that's very important to make note of, that when we square an imaginary number, we are left with a negative real number. And that's kind of interesting in my opinion. And that also leads way to I cubed and I to the fourth. If we take I and raise it to the third power, that's the same as saying I squared times I, which we just found I squared is -1, and -1 times I would be -I. And I to the fourth would be I squared times I squared, which is -1 times -1, which gets us +1. And this actually continues over and over and over again. And these are referred to as the powers of I. And it's very important that we kind of make note of these, because when we start solving equations of higher degree and just kind of more complex problems, we might get complex numbers as a solution. And we will also be talking about the operations of complex numbers. And from this point on, things open up dramatically, okay? Equations that we would just stop and say, okay, no real solution, we can now actually find a solution. It may not be real, but they may be complex. And that is the introduction to complex numbers. And I'm so excited that we finally talked about this, because now we get to cover some really interesting stuff. So I hope this video was helpful. If there's any questions, please feel free to let me know. And I look forward to seeing you guys in the next video.